Hi, everyone, and welcome to today's Germination Retail Roundtable webinar. My name is Mark Zinkowitz, and I serve as editor for Germination, and I'm happy to be your host. Today's theme is Soybean Cyst Nematode. We'll talk with 4 experts who will shed light on what they're seeing out there in regards to this disease, how it works, what it looks like in Canada, and what's being done in the way of research. Shannon and Nathan and Mario, welcome. Oh, there you are. Hi, Shannon. How are you? Hello, Nathan, Mario. Thank you for joining me today.
Thank you for the invitation, Mark.
Not a problem, and thank you for your time, sir. And before we get underway, I just want to thank our sponsors, 2020 Seed Labs and SeCan, for their support. This webinar is being recorded and will be made available at germination.ca following the event. And questions are welcomed. We'll do a Q&A at the very end of our webinar. If you have a question, please just type it into the chat box at any time, and we'll address it when we get to the very end of our presentation today. Now, this obviously is a picture of soybean cyst nematode. Soybean cyst nematode, or SCN, has been making headlines as it becomes more prevalent in Canada. According to research from Iowa State University, it is the most damaging pathogen of soybean in the United States and Canada, and it is spreading rapidly. SCN was first found in the United States in 1954. And most recent estimates show that SCN results in $1.5 billion in annual soybean yield losses. According to the research, it was found in 55 new counties in the United States and 24 new counties and rural municipalities in Canada between 2017 and 2020. Most dramatically, in New York State, SCN was found in only one county prior to 2017, but it reported SCN in 29 new counties. And Manitoba reported SCN for the first time in 2017. So this is a serious problem that we want to address today. We're going to begin with Shannon. Welcome, Shannon. Shannon is responsible for market development in Western Ontario for SeCan. She develops sales and marketing strategies to help SeCan members build their sales volumes and meet demand for new products in Eastern Canada. Welcome, Shannon.
Thanks, Mark.
Now, you're going to paint a little picture for us today of the situation in Ontario. Can you tell us a little bit about what you're telling your clients in regards to this disease?
Sure. So the first thing I actually challenge people is to start thinking about the seed itself. So years ago, we were encouraged to think about the chemistries that we use on seed, not as much about what was in the package. And in fairness, that package didn't have much. It just had the seed, where now we're looking at a lot of genes and traits that are in those platforms.
Sorry, I was still on mute. I was hoping you could paint a little picture for us today on the situation with SCN in Ontario, what it looks like on the ground. What are you seeing at the moment?
Yep. So we're seeing that it's spreading very, very aggressively across the province. There's many retails and many growers that aren't aware and they're not testing for it. We're seeing the PI 88788 strain failing in some areas because the pressures are extremely high. Yields have decreased rapidly over a number of years, but what I think has been happening is growers have tended to blame everything else but cyst. So they blame it's too wet, it's too dry, it's too cold, macronutrients, micronutrients, chemical applications, poor varieties, etc. It gets blamed for it all, where we're not really looking as well as we should be at the roots. So the picture that you have in front of you that you're looking at there right now, that looks like a perfect field, but in essence, that actually has cyst in the field. So this grower was made aware of it this year. The neat thing about this is because we were able to test and get ahead of this field actually yielded over 60 bushel beans still. But had the grower not known that it was there, you would have seen the grower continue to plant soybeans back in there again. And in fairness, because prices are where they are today, they're strong. So it makes growers want to plant soybeans because they are a good yielding crop and good pricing.
So, sorry, go ahead.
Yeah, so those are just a couple, I just included a couple of tests that I actually do when I'm looking at a field. So one being the plant disease scan, and the next one is actually a cyst test as well. I like having, go one ahead, Mark. I like actually having both tests because sudden death comes hand in hand, or Fusarium solani with cysts generally. So if you're finding one in the field, you're finding both. So in this case, we're seeing cysts at 8, and that's 100 grams of soil, and then eggs at 1,304 in 100 grams of soil. So fairly substantial, but that's lower numbers than actually some of the fields that we're seeing.
So you actually have a lot of data that can allow you to sort of gain a lot of insight into where SeCan is in a field, how much there is, and how affected that field could potentially be.
Absolutely.
So I understand, yeah, as you say here, there's a number of challenges associated with SeCan in Ontario, and our two keynote speakers today, Nathan and Mario, will be shedding quite a bit of light on this for us. But can you speak to some of those challenges that you're seeing in your province right now? Because it's as I pointed out in the beginning, it's been found in Manitoba, but it's mostly Quebec and Ontario where this disease has been found in Canada. So what are some of those big challenges, Shannon?
Yeah, so I think basically the biggest concern is that people are oblivious to the fact that it's there. You don't really pay attention, in fairness, until it's basically knocking your yields down substantially. So, you know, I think what's happened over a number of years is we've seen yields kind of slowly decrease, but not substantially. And it's easy to blame weather and all of these other issues on losing yield, because we have had some extremities in Ontario in the last 3 and 4 years. And so I think part of the challenge is that growers aren't aware. So because they're not aware, they're not recognizing the impacts and realizing what to do and how to take care of it. The neat thing is that when these tests are coming back positive, they realize that their yields have been decreasing over a period of time and maybe have been making incorrect decisions to try and fix situations that they weren't really fixing. So one example is blaming nodulation and putting down extra nitrogen when that wasn't the concern at all. It was actually cyst. So once growers realize it, kind of increases that chance that they're going to be able to combat that sooner than later, which we don't want to get those pressures too high because it takes a long time to get ahead of them and to encourage proper scouting and proper maintenance of those fields. And we have to remember that there's not a lot of control issues out there. So, you know, it's easy to fight aphids, it's easy to fight weeds and diseases in fields, but it's maybe not as easy to fight cysts, because once you have cysts, you can't get rid of it. So if you just go ahead there a slide, Mark, that next slide, I like using this because we talk about fleabane a lot in Ontario, and fleabane is a hard thing to control. But if we really got desperate, we could go out and pull every single plant, where we can't sift through the soil and pull out cyst. So we have to learn how to manage it and work with it properly. Yeah,
I suppose one potential, if there is any silver lining to this whole SeCan situation, it's that you've learned a lot and can advise other provinces now that might be seeing this.
Yes, and hopefully other provinces take note so that they don't end up in the challenges that we're facing in Ontario.
Exactly. Yeah, it's important that people learn from what you've gone through and try and apply it as much as possible to their own province. We're going to talk a little bit about testing. How does that work, and how do you advise people on that?
Yeah, so I really like testing because testing doesn't lie. It always tells the truth. You're able to see what's in the field and what issues you've been dealing with. So one thing that I like to point out with testing, I like doing a plant test as well as a soil test. The plant test will show you that sudden death or Fusarium solani pathogen that usually leads to cyst or shows that you have cyst in the field. But sometimes these symptoms can be masked. So when they're masked, we're thinking that maybe we're only dealing with cyst, when in fact we could be dealing with other issues as well. So Fusarium rots and wilts, for example, Phytophthora root rots, Phomopsis, things like that. And sometimes what happens is we look at fields and think, wow, it's Phytophthora root rot because it's early in the season, it's wet, we've got compaction there, that's what it is. When in fact, it's probably cyst that's actually opened up those roots and allowed for that disease to get in. So those tests are well worth their money.
And we're going to talk with Kim Kenward from 2020 Seed Labs right away about a new test that's been developed. So thank you for bringing that up. It's an important topic to know about. Now, what can people look for if they're concerned about SCN? What are some of the signs? What should they be keeping their eye out for, especially if this does look potentially like other diseases?
Yeah, so I tell people now to throw out the textbook. I think we're far past the textbook because we used to look for sandy knolls. We used to look for rings in the field, that kind of thing. But what we're seeing in Ontario now is that we are actually seeing it on heavier ground. So heavy clay soils will actually show cyst as much as what the sandier soils will show. It's not necessarily in rings anymore. It can be in strips. It can be across a field. It can be in tiny little patches. It can be in huge patches all over the place. So it's more important that you're understanding and looking at those roots specifically and pulling them out, digging them up and having a look and testing them if you have any concerns whatsoever that it's there. And it's not a bad thing just to test every once in a while anyway and make sure that you know what's going on in your soil.
Yeah, exactly. The more awareness, the better, and nobody knows their field better than a grower themselves. So they're the ones to recognize if there is a problem going on. And are these those nodules you mentioned earlier?
Yes, so there's some cysts there as well, but it's to understand the difference and make sure that you're identifying a cyst versus a nodule. And some people do get those confused, and so it's really important that you're able to identify cysts and what you're looking for, how to look for it, when to do those soil tests and all that. The life stages too are really important to understand. So, and I won't touch on that too much just because I'm sure your other speakers will touch on that, but it's important to realize how much they can multiply in a very quick period of time. And when those eggs sit in the soil, they can sit there for 10 plus years. So we have to keep in mind that they're not just going to go away next year. So I think the important thing is that we get to understand both the pest and the disease, because the disease itself is that Fusarium solani or sudden death that comes hand in hand with cyst. It's important to do your soil test to determine your populations because there's nobody that can determine the populations. A lab has to be able to do that for you, and to find out what else we're dealing with. Do we have Phytophthora? Is that, another cause that's aiding the problem in the field? Is it Rhizoctonia? Is it, a Fusarium wilt or a Phomopsis? So understand what else is there. We need to use a resistant variety. So we have to get away from using varieties that we have gone to in past because we love them. They're our favorites. They've yielded really well. We have to get past that. We also have to use products that will secure that variety itself, because that variety is only as good as the package that it's been given. So we need a product such as Chloriva or Saltro, and there's numerous products out there on the marketplace. So we have to take a look at those as well. And to keep in mind, the rotation is important. So it is very, very important that we're not doing a bean on bean program anymore. We're taking that field out of beans for at least 3 years if we can, and ideal is 5. I mean, if you can get hay in that rotation, it's ideal. I mean, that's not everybody's world, that's for sure, but we do have to learn to rotate because we can't be year on year the same crop.
Yeah, that's important with any disease and SCN included. So that's good for that to be top of mind for people, especially.
Yeah, so it's just really important that we remember that, like fixing a tractor, we don't fix a tractor with just a wrench. It doesn't always do the job. We need more than just one tool when we do that. And it's the same with growing a crop. We need more than one tool. We have to remember that companies aren't able to register products as easily anymore. And with SeCan, I'd like to point out that it is very, very challenging to get those genes in the soybeans themselves and keep that yield as high as they can. So we have to do our due diligence as growers and as retails and as seed sellers to make sure that we're maximizing on those technologies for as long as we can. And the other thing to really point out is that movement. So SeCan can move any which way. And again, I'm sure our speakers will talk about this, but wind and water erosion, seed, any equipment, anything that's moving back and forth from field to field, make sure you're doing your due diligence. If you know that you have it in one field, make sure you're cleaning your equipment properly before you're moving it into another field. Do as much as you can to prevent the problem. And I think the important thing that I've learned with dealing with this pest specifically and with this disease is that it's okay to admit that we don't know it all, because we aren't, we're only general practitioners and not neurosurgeons. So we can't expect retailers and growers to know it all, because everybody is busy. It's a disease that may not necessarily be easily identified because it can be masked by other diseases, but the best takeaway is that a misdiagnosis can cost. So if you're a retailer, it will cost you. If it's the grower, it will cost. So understand if you do have cyst in the field, and understand that tight rotations cost. And like I said before, don't go back to a high yielding variety just because you like that variety, because it's only a poor Band-Aid fix and you're creating your own compaction without even really driving over a field. So make sure that you understand your genetics and you understand the platforms that are behind that seed. It's really important as seed sellers and as growers that we're not basing all our decisions strictly on yields. There's some dynamic varieties out there with some really great yields, even with the cyst traits in them. It doesn't pull down your yields. So understand the importance of the genetics behind that seed, because it may get to be more important than what your herbicide and fungicide applications ever can be.
Good advice from Ontario. Thank you so much for your time today, Shannon.
Thanks, Mark.
We'll see you again shortly during the Q&A.
Okay.
Now, as I mentioned earlier, testing is really important. I talked the other day with Kim Kenward from 2020 Seed Labs for a few minutes. I pre-recorded a chat with her in regards to a new test that they have developed. I wanted to chat with her because I wanted to know how this new test works and how it's different from traditional tests that extract nematodes from soil with a device called a Behrman funnel. The new test uses polymerase chain reaction, or PCR technology, which is a high-tech method to extract, increase, detect, and identify DNA in a sample. So I'm just going to play my chat with Kim now. It's about 7 or 8 minutes, and then we will hear from our keynote speakers of the day. Well, Kim, thank you so much for joining us on the webinar today.
Well, thank you very much for inviting me, Mark. I'm really starting to look forward to these things as being a major source of social contact during my work from home episodes.
Yes, and that is important, of course, during a pandemic, so thank you for that. Kim, we're talking about soybean cyst nematode today. Why does this concern you as R&D manager for 2020 Seed Labs?
Well, one of the things that we actively do as a seed lab is that we try and anticipate what's coming in terms of agricultural challenges up ahead. And we would like to put testing options in place ahead of time to help deal with them before they become really big issues. We can pivot quickly to new testing if we need to, but we prefer to actually do everything thought out beforehand and have it ready before we actually need it. So SeCan hasn't been a problem up to now, but there's been lots of evidence of increasing acreage of the soybean since we got access to the early maturing varieties. And with the deregulation of SeCan as a quarantine pest in 2013, we're not that surprised that we've been seeing colloquial reports and some academic reports of it being found, and now we're starting to hear about it showing up again in previously identified fields. So this is going to become an issue, and we're just trying to stay ahead of the ball on it.
So Kim, this test you developed for SeCan, can you talk a little bit about how you developed it?
Well, we always start by looking at what's already available in terms of testing. And we then evaluate our ability to deliver them as set in normal practices. And we look at then the strengths and weaknesses of that approach and see how we might be able to improve on it. And if that's something that we can do and it adds value to the test. So those tools can include looking at lots of the very important published academic work that's available on the subject, as well as the personnel that we have in our lab, what our expertises are, and the equipment and technologies that would be needed to actually make a new test happen.
Kim, what were some challenges surrounding this test? Can you talk a little bit about that?
Well, when we did our strength and weaknesses analysis of the existing test, what we really liked about it was relatively simple. It did a nice large size sample, and it really used a minimum amount of equipment, and it was very fast. The problem was the size of the sample wasn't something that we could easily match on a DNA approach. And we were looking to actually increase the sensitivity of the test, because one of the basic weaknesses of the traditional Bieman funnel is that it really only looks for the live motile forms of the nematode. And we know that since we are looking at very low levels of infection right now, that we're not going to find a lot of those motile forms. So we need better sensitivity in order to be able to detect the much more prevalent dormant forms that were going to be like the cysts and the eggs that were happening rather than just the living, moving juveniles. So what the biggest challenge we had there was we knew we could match the speed. We knew we could use the DNA testing methods to deal with the problem that the Bieman funnel has with needing expertise in nematodology identification. But we needed to actually do something that would match the simplicity and the size of the sample that needed to be analyzed.
Kim, as you know, SeCan is not super widespread in Canada, at least not yet. What are some future potentials you see for this test?
Well, right now we see it as a tool for monitoring for the establishment of the nematode present in Western Canada. We know that it's just starting. We would like to be able to use our test to see it, to figure out, screen the fields that are at risk and check whether or not we're actually starting to see the SeCan expand beyond the known fields that it's present in. From there, we would like to actually see if we can expand the time range at which we're sampling. Right now, because the Bieman funnel precedent is based on trying to capture live motile nematodes, they're very restricted in terms of when you can sample your fields, and they're very reliant on visual assessment of plant tissues. So we'd like to expand our test capability into actually testing the tissues as well, and into looking at parts of the field that you aren't necessarily expecting the nematodes to happen, and at different times of the year. With that information, we would like to look at a longer possibility of potentially linking the levels of soybean cyst nematode that we see and that we can potentially quantitate with a DNA-based test, and equate that with what you might be able to expect in terms of yield losses at the load of pathogen that you have present in your field.
What are some of the strengths of the PCR-based test? Can you touch on that a little bit?
Well, the Bieman funnel itself is very reliant on a nematodologist basically able to accurately identify the nematodes that they find under the microscope in the sample that you extract from the soil. Those guys are you're looking at very small differences on little creatures that move very fast. So it's not the easiest thing to do. Plus, the Biermann funnel is very reliant on them being motile, because that's how you extract. With a DNA-based testing, what we can do is that we're actually just determining the species of the nematode at the DNA level. So we're not reliant on the motile juvenile forms. We can actually do an identification of the nematodes based on the cysts or presence in the plants, or the eggs themselves, or the juveniles. So it's both dormant and living motile forms that we can actually detect with the DNA. So that eliminates the need to actually have a specially devoted person that can identify quick-moving, little difficult to identify nematodes, and you can do it against a larger background.
Speaking of piloting it, how can people take part in this? How can they go about having their soil tested? How do they go about actually using the test?
Well, it's going to be a standard sample that we would accept into the lab. So they just need to go out and they need to collect the soil sample as they would normally for a Biermann funnel test, which is that you're going in along the rows of the soybeans where they were planted, and you're digging down into the soil. And you need to be somewhat lower, like you need to be a good 2 centimeters down, because the nematodes don't really like being near the surface because it's very harmful to them. And then you're just collecting that soil core sample, and then you're sending that in. You don't have to be as worried about preserving the sample as you would for a Biermann funnel, because a Biermann funnel needs to preserve live nematodes in there, and we're not as concerned about that. But if we do happen to find a positive, it would be nice to be able to run a Biermann funnel on it so that we can check how the results compare. I'm expecting the Biermann funnel to be lower.
We shall see what happens, but that's part of the fun of doing new things. So it sounds like there's a lot yet to come. So keep us up to date.
Thank you.
Thanks for your time, Kim. Have a great day.
See you.
Thank you so much, Kim, for that. We will now begin with the first of our 2 keynote speakers. Nathan Schroeder is a plant pathologist at the University of Illinois. Welcome, Nathan.
Thanks, Mark. Great to be here.
Thank you for your time, sir. You are going to give us a snapshot of the situation in the United States with regard to SeCan and some of your work regarding it. So I will turn the floor over to you.
Great, thanks. So yes, I'm going to talk a little bit about soybean cyst nematode in the U.S. We've had it here for many decades, as Shannon had mentioned. I'm at the University of Illinois in Urbana-Champaign, and we've had SeCan in Illinois for probably as long as I've been born. So I first wanted to start off this talk by mentioning a website and organization that I belong to called the SeCan Coalition. So this is a group that's funded by the United Soybean Board in the U.S. Includes nematologists and plant pathologists from across the country, as well as from Canada, and really talks about SeCan management strategies, biology, everything you'd really want to know. So it's a really great website to check out. So one thing that Shannon mentioned, and I believe Mario will be talking about, is the spread of SeCan. So I realize I'm talking to a Canadian audience, and it is very likely that the SeCan came from the US, and I believe Mario will talk about that. Shannon mentioned that it's easily moved through soil. While we do deserve some blame in the United States, we can't take all the blame, because it did not originate in the United States. We believe it originated in Asia. As Mark mentioned, it was first found in 1954. Soon after that, in counties in the Midwest, and it really has expanded since that time to all of the soybean growing regions in the U.S. So you can see in this 2020 map, all of the counties in Illinois and all of the counties in Iowa, which are the two largest soybean growing states, are positive for SCN. I wanted to spend the bulk of the talk discussing what are the current recommendation strategies for SCN management that we give as part of the SCN coalition to our growers here in the United States. And really we can break these down into three, which actually Shannon mentioned. So the rotation to non-host crops, the use of resistant soybean varieties, and then considering some of the seed treatments that are available. And here I've shown also in this slide an image of what SCN looks like on the roots at certain developmental stages. So these white, sort of pearly white structures along the root are the adult female of the nematode. And this is a stage where you can actually see with your bare eye the nematode present. At other developmental stages, when it first starts off, you can't see it except with a microscope. And so I wanted to briefly go through the life cycle of SCN. So the nematode starts off as a microscopic egg, which is not visible. So it's about 50 microns in diameter, very, very small. This will hatch into a worm-like structure, a second stage juvenile, which Shannon was talking about. And it's this hatch juvenile which will infect the plant. And once it infects the plant, it will set up a feeding site that it will remain at and feed at for the rest of its life, basically. Now in SCN, there are both males and females. The females will never move again from that feeding site. So once they're start feeding, they never stop until basically they're dead. The males will go back to a worm-like shape and go in search of females to find for reproduction. The females can produce anywhere from a couple hundred to several hundred eggs, and then those eggs can survive in the soil, as Shannon mentioned, for multiple years. And this actually becomes pretty important when we talk about control strategies. Once the female dies, her body will actually change color from sort of this whitish coloration into a dark brown color. Once it gets to that dark brown color, even though it's large enough that you could see it with your bare eye, it becomes so hard to discern it against sort of the background roots and soil particles that are in the soil. So it is really important, as Shannon mentioned, to test, because you could dig up roots and you may see these adult females there if you catch it at the right stage, but it's possible that you'll miss those nice adult females, but you would still have SCN in your fields. So the first strategy I mentioned was rotation. So in comparison to some of the other plant parasitic nematodes that are out there, SCN has a relatively limited host range. It will feed on some other species of plants besides soybeans, but there are a lot of non-host crops that growers can choose from to rotate with soybean. Now in the Midwest, corn is really the primary rotation crop. So in Illinois, we really have only corn and soybean grown here. There's a little bit of wheat, a little bit of alfalfa, but most of the agriculture in Illinois, the plant agriculture, I should say, is corn and soybean. And corn is a great non-host crop. So during years where corn is planted, the nematode is not reproducing, it's not increasing its population size. And in fact, a certain number of the nematodes will die off during that corn year. However, you will not get a complete control by just planting corn. And the reason is because as we know, and we've talked about so far, SCN can survive as an egg, and it can actually sense when it's in the soil if soybean has been planted or if corn has been planted. And in years where corn is being planted, it tends not to hatch as much, and they'll just hunker down in that egg stage and can remain around for another soybean year. So while corn is important for limiting the increase in the population, it's not going to totally eliminate an SCN problem. The other main control strategy that we always recommend is to use a SCN-resistant soybean variety. The great thing about SCN resistance is that it's not costing the farmer any extra dollars. So you buy an SCN-resistant variety seed, it doesn't cost anything more than an SCN susceptible variety. And in fact, in the US, it's actually very challenging to find susceptible varieties with the appropriate maturity group in most parts of the US. When I'm conducting my own research, finding a susceptible control seed is oftentimes challenging. I just wanted to illustrate the point of what can happen if you don't use a resistant variety. So this was from research plots from a field near us in Urbana, Illinois. These were various plots. We had used a susceptible variety in this particular research, and we sampled at the beginning of the year at planting, and we saw very, very low number of eggs at planting. So some of the plots, we didn't find any eggs. When we went at harvest, we found several thousand eggs in each of these plots. So from a very, very small initial population, SCN can really explode if you don't use a resistant variety. So I showed those egg numbers, and I just wanted to mention, for those of you who may not have a good idea of what's a bad number of eggs or a good number of eggs. These are sort of the rough thresholds, if you will, for SCN that the SCN Coalition is mentioning. It's important to realize that these are sort of general estimates, and so local conditions can really affect this a lot. But generally, if you're getting over 4,000 eggs per 100 cubic centimeters, you want to be somewhat concerned. But even at those low numbers, if you don't plant a resistant variety, you're going to increase the population very quickly. So we do have a lot of resistant varieties in the US, but the issue, and Shannon alluded to this a little bit in her discussion, is that if you look at least at US varieties, really the only resistant variety, or I should say the source of resistance that's out there, is this PI 88788. So PI stands for plant introduction, and 95% of the commercially available SCN resistant varieties that are out there derive their resistance from this one genetic source. Okay, so an example, I just went, before putting this talk together, I went to Pioneer, pretty large seed company. In my area, if I put in my zip code, they offer 17 varieties that they recommend. They all had actually SCN resistance, but 16 of those varieties had resistance from this PI 88788. The other single one is from another genetic background called Peking. To illustrate this point more, I have some data from my colleague Greg Tilke at Iowa State, who sort of tracked the abundance of resistant varieties over time since he started his faculty position back in 1991. And here on the y-axis is the number of SCN resistant varieties, and we can see it's increased over time. But for each of these bars, the total height is the number of SCN resistant varieties, but the red portion is the portion of those varieties that get their resistance from something other than PI 88788. So even though the total number of resistant varieties that are commercially available has increased quite substantially over the past couple decades, it's remained the case that almost all of them derive their resistance from PI 88788. And so you can imagine what can happen if we use the same genetic background year after year after year. Well, just like with herbicide-resistant weeds, the nematodes can evolve to be able to combat this SCN resistance. And now we're seeing more and more of these SCN populations that can reproduce on 88788. So this is just another set of data that was plotted over time from 2000 to 2019. Again, this data are from my colleague at Iowa State, showing how different populations within Iowa have responded to PI 88788. So ideally, you would want these dots here to all be below this 10% threshold line. So this y-axis is showing how these nematode populations, how they reproduce on P888788 relative to a susceptible variety. So if you have a really high value, close to 100%, it basically means that PI 88788 is doing nothing. A really low value means that 88788 is giving you perfect control. And what we're seeing is that over time, the nematode populations have shifted and are now, while PI 88788 is still effective at controlling the nematode, that efficacy is becoming less and less. So we're starting to get really concerned about this, and we're recommending growers rotate their resistant sources whenever possible. The last component that Shannon mentioned are seed treatments. There, at least in the US market, are about a dozen or so different seed treatments. We're still trying to get new data on these in terms of looking at their efficacy, but it is something to consider to add in combination with resistance and rotation. And then Mark had asked to briefly talk a little bit about what my lab does. So we're very interested in the biology of the nematode. We're currently looking using a technique called electron microscopy, where we basically take this nematode and make really, really thin sections of it, kind of like very, very tiny cheese slices. And we look at it under this high power microscope that allows us to basically reconstruct the body of this nematode to find out how the nematode is put together and how the different cells within the body of the nematode are acting together in order to be able to parasitize your soybeans. And with that, I want to thank some of the funders for my work, and I'm going to pass it back to Mark.
Thank you so much, Nathan. Great information, and it really helps us here in Canada to get that comprehensive picture of the American situation with this pathogen. So thank you very much, and we'll see you shortly for our Q&A. Now, last but not least, before we get to our Q&A and sign off for the day, we are going to hear from Mario Tenuta. He is a professor of applied soil ecology at the University of Manitoba. Welcome, Mario. You are going to give us a snapshot of the Canadian situation. Welcome.
Thank you, Mark. I'm going to try to share my screen right now.
By all means, I will turn the floor over to you, sir.
Okay, can you see that, Mark?
I can indeed. Looks good.
Okay, excellent. Well, let's launch into it. How much time do we have, Mark, for me to speak?
It is 12:44, so we have another 15 minutes or so.
Okay, so as Shannon and Nathan have mentioned, there's I call it the Great March Northwards of SCN from the United States. A few years ago, I used to say that we need to build a wall with the United States to keep soybean cyst nematode out. But you can see it's pretty futile in Quebec and in Ontario, and where it's present now for quite a while, a few decades in Ontario, and then recently since 2013 in Quebec. And I'm going to dwell quite a bit on the Manitoba situation because it seems to be the next frontier. The situation in Ontario and Quebec, Ontario at the top, you can see the southwestern and eastern southern Ontario are where SCN is present. Northumberland kind of sticks out, being coastal with Lake Ontario. And the idea really was, or the observations were, SCN came across Essex this way with the land border, and then also this way through New York State to Ontario, and then up the St. Lawrence Valley into Quebec. So it's being readily able to move in Canada. Our temperature, winter temperatures don't seem to have stalled it in southern Ontario. There's questions about Manitoba about that, and as I'll show you, our winters here don't provide us that protection of keeping SCN out. We started in 2012 and doing surveys in Manitoba as in North Dakota, Minnesota, SCN approached the border with Manitoba. And we sampled then over this period of time, 76 soybean fields. Almost 6,000 soil samples were taken, 500 composite samples processed, and we prioritized areas closer to the United States where we may have flooding from the Red River Valley, bringing cysts in. Fields with more than 3 years of soybean having been grown on, and not consecutively, but in their history. You have to remember soybean is fairly young in terms of as a crop, oilseed crop in Manitoba. So we've had quite an explosion in acreage over the past 10 years. So we're now getting, you might want to call mature fields where they've seen more than 3 years of soybean having been grown at some point. We also have the history of dried edible beans, which I'll get back to in a moment. And so we sampled prone areas to soybean cyst nematode entry. And we found some cysts, just a very few cysts. These are some cysts really busted up and not super pretty. We found some juveniles, but when we did our analysis, nothing in terms of SCN. And this is how we have to analyze for and recover soybean cyst nematode. We have to do something, we have to float the cysts, actually. We have to float the cysts and take advantage of the fact that the female cysts are lighter than water and will float, hence why they can move in flooded water. And they're very light too, they can be moved in the wind as well. We actually analyze 5 pounds of soil, and we use something called the USDA cyst extractor, which is designed for nematode cysts. And we have to use 5 pounds because we're starting off with low populations, we believe. And therefore, when we're screening and trying to find populations, they're going to be in extremely low levels. So that's hence our approach here. But we found nothing on our first crack at this, which is a good thing. We developed a molecular PCR test using a mitochondrial gene, and we use this gene. We've proved that this gene works for various SCN populations from around the world and is negative, doesn't work for other non-soybean cyst nematodes. So it has a good fidelity. But we couldn't find any positives with our PCR test of the cysts that we found, and we were subsequently later to characterize them as different types of cyst nematodes. This is important because there are cyst nematodes in soil that are not soybean cyst nematode. And in the prairies, we see a few species of non-soybean cyst nematodes. They're not problematic for agricultural crops, and I kind of say they're the remnants from our prairie grasslands and possibly from weeds growing in fields. But anyway, we couldn't find SCN then. We took another stab at it in 2017, 30 fields. This is my PhD student, Nazan, in here. We, again, southern Manitoba along the Red River Valley, and we had an oddball up here that we suspected might have SCN here, the field to the northwest. And we did find now cysts, more cysts, put it that way. Not too many, look at this, 1, 2, 4, 14 per kilogram of soil. We did PCR, 2 different PCR tests, and we were able, and then we followed that up with DNA sequencing by a few genes and looked at the morphology, and everything was consistent with SCN being present. So we were able to confirm in this cycle of tests 4 fields, 4 commercial fields in Manitoba that had extremely low levels of SCN. One of those fields, actually luckily the one with the highest levels, the 14 cysts per kilo of soil, was growing soybean the following year. And we hunted and hunted the roots in that field, and we found just 1 cyst on a root sample here, and there she is. But, you know, that's not enough we couldn't get a population off this to grow in the laboratory on soybean and so forth like that. This is the results as of 2019. 4 rural municipalities in Manitoba with SCN towards the border, and this is the Red River Valley here, so that flooding likely coming up this way, and that's where SCN is present up in this area in North Dakota and Minnesota, and we have this in North Treeherne rural municipality positive field here as well. A little bit of an oddball. This one I don't suspect would be flooding from the United States, but via some other mechanism of introduction. Particularly, I'm suspecting it was used farm equipment that would have come across the border and wasn't cleaned. But it could be birds, wind maybe. Now, something happened this year. We got a phone call from an agronomist, crop consultant, saying there's a really bad patch of soybean late June, and this is the patch here, and you can see the yellowing, the stunting. You can see that this portion here is probably not going to close for canopy anytime soon, and you can see the good areas over here of soybean. And when looking at the soil, you can see cysts here, and let's see if this works. And this gives you an idea of what sorry about the out of focus at times here, but it gives you an idea of the cysts that we found on these soybean roots in that patch. And this is typical. You find these patches of areas with dwarfing and chlorotic soybean plants, and they're near entrance points, headland areas, depression areas, sloughs, drainage ways in the field, areas that we think are more susceptible to introduction of soybean cyst nematode. Now this field, of course, not of course, but you don't know, but it was light textured soil, and we had very, very dry conditions this year. And so there's an overhead shot of those plants. You can see the chlorotic and really stunting. Here's the back of a truck bumper. You can see the roots with the cysts. In the laboratory, we grew the soybean, and we were able to confirm the presence of soybean cyst nematode. So we were able to prove that we could take the nematode from the soil and then infest soybean in the laboratory. So we're pretty confident, and we did the molecular analysis with our PCR tests and also sequencing to confirm that it is definitely 100% a soybean cyst nematode in quite high levels, actually. So we're talking over 2,000 eggs per 100 cc's or milliliters of soil. So pretty decent amount. I was quite shocked. Now that isn't levels of a field that just started to have cyst nematode, soybean cyst nematode. That's a field that's had it for a while. Okay, so this is the field actually, and the patch is down here. Okay, that we had sampled. So we went back and we resampled that patch in much more detail in September, early September. And now look at it. Here's a maturing of the rest of the soybean field, but this field is green. And lo and behold, we had a rainfall that just happened in very end of August, beginning of September. And what happened? Well, those stunted plants perked up. They're green now. That shows you the effect of moisture. We wouldn't have seen this patch being dwarfed and chlorotic in a wet year. And even, I've not maybe Nathan's seen this before, but this is really striking to me. These plants perked up with the moisture, and they wanted to continue and almost even flower and for sure try to set some pods here and fill. Didn't do a very good job of it, of course, and you can still see they're not going to close their canopy, right? But very remarkable. It tells you really that interaction with moisture. So we sampled this patch, and we wanted to know, well, what you see, is it where the nematode is in this patch? And here's the grid that we sampled, 0 to 70 meters along the side of the road, and then into the field, 0 to 24 meters. And here's the edge of the road, the gravel road, and the plants are planted right up to the edge of the gravel road. And you can see there's a hot spot of the nematode, over almost 5,000 eggs per 100 cc's of soil, right in the center of that patch. And if they go into the green area, a nice, good-looking soybean, when we sampled, it wasn't green, it was maturing, 0. And same over here on the edges. But right along the roadway, a slow amount, which is quite interesting. So it really does, that patch really is an SeCan patch, okay? And that plant effects in terms of the compromise of their health is because of SeCan. So we have to upgrade our map, and here it is. And we have to add the additional RM here to give us 5 RMs now in Manitoba with SeCan. So ongoing, we've sent populations of our nematode down to University of Missouri, and Caitlin is determining the I want to say the resistant type of the nematode. Okay, and now we're going to sample 1 acre grids of that whole entire field to see if there are other patches or other locations in that field with SeCan to see how it spreads in that field, or if it's still isolated to that patch or not. It really tells us something about implications for management for farmers. Okay, we plan a new survey in 2022 with the partnership of the Manitoba Pulse and Soy Growers, and we're gearing up to be part of a national program and for tackling SeCan across Canada in the new CAP funding framework. So I think we don't have too much time left, do we, Mark? Huh?
We've got another couple minutes here, Mario. So yeah, feel free to finish off.
So some slides from my brother, who's a field plant pathologist with OMAFRA in Ontario. And, you've seen this already with Nathan was showing. We have the 887, 88 resistance, and good, unfortunately, overcoming of the resistance in SeCan populations in Southern Ontario, and it seems to be increasing over time as well. And there are other HG types here, and there's also resistance to other sources. So you don't see zeros across the board here. Here's pretty low here, but we do have there are other genes around there. 887, 88 is the most common in our genetics, and it is becoming it's being overcome and increasing over time. And here's I find this interesting. My brother passed me this to me, and The big orange areas are that overcoming of that resistance gene that we just talked about. But the green are populations that have no resistance. So the resistance genes that we can put into genetics will work against those populations. I find it interesting that those populations with no ability to overcome the plant resistance are next to fields that have overcome. This is quite interesting. I would have thought it would have been more getting uniform. I guess over time it may become more uniform. So it looks like to me that there's founding populations of resistance throughout southern Ontario. And work from a colleague in Quebec, Benjamin Mimi with Agriculture and Agri-Food Canada, with looking at the genetics of populations of soybean cyst nematode from North America, has identified really there's kind of two lineages of SCN. There's the northeastern lineage that's moved into Ontario and Quebec, and then there's a northwestern lineage. Manitoba wasn't part of this because we didn't have the nematode when he did the analysis, but we've provided the nematode to Benjamin, and we'll see, but I'm pretty sure that we'll be part of this northwestern lineage as different from the northeastern here. Now, a couple of key points here for everyone to know, and that is there are other hosts of SCN, and particularly some of our dry edible beans like kidney beans. Now, this is really important because Ontario and Manitoba, and then even Alberta, where soybeans is becoming more common, is an area where they also have edible beans as well. So you have to keep in mind when you have soybean and edible beans, thinking about them as all being hosts. And so your management and your rotation needs to take that into account. Okay, very important here. And you can actually there's an example here in Minnesota where there was a disease loss on kidney beans. And yeah, another thing that what rolls in after SCN becomes established is sudden death of soybean caused by fusarium, and they go hand in hand. Usually SCN comes in first, and then fusarium follows. So there's, synergistic effect here, or nursing effect by SCN. So you got to keep this in mind too. Now we've just, my colleagues in North Dakota have just found it right at the border in North Dakota to Manitoba. So now this is something that we need to contend with in Manitoba. And of course, Ontario has already been contending with sudden death syndrome. And anyway, so now we can update this with Manitoba up here now. With the Great March northwards. Integrated management at SCN is required. I don't think we're going to have enough time. I'd like to just open it up, but there's a lot of things that growers can be doing, and I'm interested in fielding questions on that if you want, and symptoms and a whole bunch of other things. We're just going to pass on that and just go to the last slide here and say thank you very much.
Thank you, Mario. That was terrific. We'll have a brief Q&A session now. If you have a question, please type it into the chat box at any time. Shannon and Nathan, you're free to join us for our Q&A. And again, if you have a question, please type it into the chat box now. So now I have a question here regarding the way that SCN spreads. Is it spread via soybean seed, or is the movement of machinery more important?
Well, I think it's going to be the soil is going to be the critical thing here. Soil and cysts. The seed should not be an issue. It's not a seed-borne or foliar or above ground issue at all. Now, if you have soil tags or soil that's come into your seed, then yeah, that could be an issue, but it's not truly a seed-borne issue.
Yeah, that's important. So, okay, so not seed-borne. Okay. I have a question. Shannon, you mentioned using products to control SCN. This person asks, if controlling SCN will reduce SDS, do I need a product that controls both SCN and SDS? Would a product for SCN be good enough for control of SCN along with SDS?
Yeah, so, and I'll get Mario and Nathan to give their comments on this one as well. My experience is that generally we're combating both issues now. Anywhere we have cyst, we have SCN. SCN and sudden death are coming hand in hand. So a product like Saltro, and I'm a little leery to speak too much on that because that's not my product, but that product, my understanding is, was just registered for both sudden death and cyst within the last 2 weeks or so. And they're working at the higher versus the lower rates on that product. But I like to see a product that controls both if I'm looking for both and wanting to control both. And I guess where I stand on that is in regards to cost. I mean, if you're applying one, you know, it's not that much different to be able to control both at the same time.
Nathan or Mario, any input?
Yeah, so at least in the U.S., I mean, we certainly see that association between SDS and SCN in the U.S. and especially in Illinois. We do have a lot of SCN is basically everywhere, whereas SDS is, while prevalent, is not necessarily everywhere. And so I think it does go back to, you want to know what you specifically have in your field. So certainly some of these products are marketed for both control of SDS as well as nematodes. The Nemco is derived from a biological, and I believe it's only marketed towards the nematodes. And so if you know you have SDS, I would not necessarily just rely on a nematode specific control to take care of both.
I would agree with that. Even our nematode control products, they're not going to be 100% effective. And so you still have presence of soybean cyst nematode. It may drop it below some kind of economic effect in terms of on yield, but you still can have that synergistic effect on the two pests together. So yeah, I don't think you can just rely on one without trying to attempt to knock out the other.
Two questions kind of about the same thing, so I'll try and combine them. Are there any trials with non-host crops that can suppress nematodes? And are there any non-host rotation crops being tested in the US and Canada?
So there is a lot of research being done out there in various locations, testing the idea, using the use of green manures against plant parasitic nematodes, including SCN, to put years worth of research into a single sentence. The data are mixed, that sometimes you will see control efficacy and then sometimes you won't. So Mario will probably have greater insight into the results of these trials than I will.
Yeah, I haven't seen anything yet that is really striking. Not with the cyst nematodes. With other nematodes, yes, that are non-cyst nematodes. They tend to be easier to control than cyst nematode with their longevity in the soil, so it becomes more of a challenge. The big area that's also being looked at is cover crops, because cover crops are becoming very important, and the question now becomes, well, can we get some generations on the cover crops? And so there's a mix there as well, in terms of some cover crops may very well be able to do that, others don't, in terms of being able to sustain populations. So yeah, nothing quite yet like what we may have with Pradolenchus or some other nematodes that we can grow some green manure or trap crops. Nothing so lucky so far.
Is there a way to quantify yield impact of SCN?
Well, an easy way is to mix up your seed, do some strips in your field, and see the benefit of the resistance genes, and then you may be able to get something from there. The genetic potentials are getting really close, or if not, they are close. They are the same between resistant and non-resistant varieties. So you could be doing that.
I think the other thing to note is, from a plant pathology standpoint, we always talk about the disease triangle, which includes the host, the pathogen, and then the third part is the environment. And so, even though you might think, oh, this is a below ground pest, so environment won't matter, it is certainly the case that the impact on yield, there is an interaction with the environment. So in years where you have, let's say, drought, you might see a greater impact on yield in that interaction with the nematode pest. So I think Mario and I were both smiling because it is challenging to put a precise number on it.
I'd like to point out too, Mark, that one thing that I've noticed in Ontario this year is we've tended to see fields that have had resistant varieties planted into it, and where we know that there's cyst pressures, and those yields have, those beans have gone downhill quite quickly, like some of the pictures that Mario had in his presentation, and then they were able to overcome that pressure and then come back out of that and still yield well.
Yeah, I suppose there's a certain element of learning as we go, especially here in Canada. And so as more research is done in the future, I'm sure we'll have a clearer picture of issues like these. And so, no, thank you, everyone. That's actually all the time we have today. And so I wanted to thank all of you, Shannon and Nathan and Mario and Kim, for your time today. Great presentations, guys.
Thank you, Mark.
And I just want to take an opportunity to thank our sponsors again, 2020 Seed Labs and SeCan, for their support. And again, this webinar will be made available at germination.ca very soon. And thank you to our audience for spending your lunch hour with us. I hope you found this information valuable. And as this is a topic that is just beginning here in Canada, especially in Western Canada, we will be doing more webinars on this topic in the future, no doubt. So please join us again for those. On behalf of myself and Germination, have a great day, everyone. Take care.